Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Research has shown that utilising exposed timber increases our connection with nature and is one of the major elements of biophilic design, with proven benefits in well-being and productivity. It is also commonly desired by architects for the beautiful finish and by developers for market differentiation. The performance solution and engagement of fire engineers allows designers to utilise a much higher proportion of exposed timber structure. Today we're speaking with Rob Dixon and Travis Stirling, who are both senior fire engineers at Arup, on their perspective on how to achieve the performance solution with more exposed timber. So in this episode we discuss all about the risks and the solutions for exposing timber in mid-rise timber buildings. If you want to learn more about the DTS provisions, I suggest you listen to the previous episode where I speak with Paolo Levici and Boris Iskra. Without any further ado, we'll get into the interview with Robert and Travis.
Yeah. Okay. Well, I suppose the first thing we need to look at is the other characteristics of the building. So size, number of stories, floor plate. Is it open plan? Is it going to be cellular? Is it residential? Anything. All the characteristics of the building that we're designing for. And the second thing, probably from an architectural perspective, is to understand, what their architectural sort of aims are. So, if they're specifically wanting to expose timber because obviously it looks beautiful and, it shows off the sustainable credentials of buildings and things like that. And there's, lots of well-being positive issues about timber buildings. Obviously you're going to want to look at some of the timber. So then we need to understand, how much of the timber do you want to look at? Because for a bigger building, a higher risk building, which I think we'll probably get into later on, there's the design needs to be more and more stringent, basically, the higher risk the building is. And then, we can sort of start discussing things like how much of the timber they want to look at. We could try and sort of come up with a number, a safe proportion that they can expose, and also whereabouts in the building they can do it. We can come up with some sensible details to kind of, break up the continuous combustible surfaces and things like that, and just work through things like that to try and sort of reach the architectural intent, but also to make sure we're designing within the sort of safe parameters. So sprinklers operate generally between about 93 and 99%, so they're very reliable. So, but for the highest consequence fires, we must consider the 5% or the 1% where they don't work. So this is everything we do after that for a structural design is a redundancy design, but it's just to address the highest consequence cases.
I think what we're seeing is there's a really good degree and a good degree of confidence in tying it with where a lot of the costings are coming in at the moment, and from even reading this and from even what you guys have been producing, we're seeing that mass timber is really applicable in that sort of 5, 6 to maybe 10, 11 story category. And then underneath that, you're probably more in a stick frame or even some other forms of construction. And above that, you're probably reverting to concrete and composite construction. So in that mid-range, on the lower bounds of it, sort of 5, 6, 7, and pushing 7, you're probably looking at a good confidence in exposing a fair amount of the timber. At the upper bounds of it is probably just when it needs to be applied with a bit more rigour and scrutinised a bit heavier. It's not saying that you can't do it. It's just saying that you really need to have confidence in the calculations and the data that you're using.
And at the very high level, what are we trying to achieve with fire design? What is the FRL, and why are FRLs the duration that they are, and what is the whole goal, and how does it relate to, say, fire brigades and so forth?
So the FRL, as per the DTS, is basically it's just a standard measure of fire resistance. So a 120-minute FRL building won't necessarily last 120 minutes in a fire. All that means is under a standard fire test, so a furnace test, it demonstrated performance to 120 minutes or 60 or 90. And then that's just a method by which you can compare that particular element to another particular element. So it's slightly confusing that it's in a time period, because it doesn't really mean how long the building will last. And I think that's an important point to make about FRLs. But in terms of like timber design, what we're trying to achieve, it's exactly the same thing. An FRL of 120 minutes means this timber element will last 120 minutes when exposed to a standard fire exposure. Yeah.
But then I think some of the critical application of that then, or taking what Rob's saying further, is when we are looking at an exposed timber structure, we then are looking at some additional fire load. So timber, I guess you start with the basics of having the BCA, and I guess a lot of building codes started with concrete and steel. And we're looking at a non-combustible structure. Sure, they've all got different mechanisms of failure. And I guess what we are, except we've fundamentally got a non-combustible structural element. So it's not adding, when we look around the room, we've got a number of combustible surfaces. And once they've been burnt, essentially, that you will achieve burnout, or there might be conditions which don't continue to support burning. When we've also got a timber structure, whether that be the structural elements, the soffit, or other areas that are added, we are adding load into the fire compartment itself. So fundamentally from, I guess, say a concrete building into a timber building, when it's exposed, so I guess that's the key part, when it's exposed, you are adding additional load, and that needs to be considered and assessed by the fire engineer to show that it's adequate. And I guess that one step further then is taking it from, you need to also show why it's appropriate when exposing timber to have the same FRL and not necessarily consider it going up or possibly bringing it down. So I guess by adding the extra contribution of the fuel load.
So is the whole goal of fire engineering mitigating risk? So would you like to talk a little bit about what risk is? And I'm stealing a bit from your presentation slides that you had last year at one of our seminars, but if you talk a little bit about that, and then we'll move into some of the unique risks of timber, and then we'll move into how to mitigate these so that it's as safe as all other buildings.
Okay, so I think a fairly commonly adopted risk framework is risk is approximately equal to probability times consequence. So and as you get bigger and bigger building, risk is generally constant within a building. So there's a constant acceptable level of risk, let's say. So as you get to bigger and bigger buildings, the consequence grows. So therefore the probability must drop. So the probability of fires you must consider for a higher consequence fire to keep a constant level of risk is a lot lower.
Just adding further to what Rob touched on, certainly I completely agree, and that's sort of how we, I guess, assess most buildings and building designs. The bit that I want to add is that it's pretty critical to ensure that with increasing height, that you're liaising with the fire brigade and ensuring that that they can, I guess, with a upper medium rise and a high rise building, that they're more likely to now need to come into the building, conduct search and rescue, and they also want to be known to have a safe environment to at least get into the building in. They obviously would understand that once they move onto a floor plate, that they may be confronting conditions that they're not, that they're dealing with in numerous building fires. So that's the bit that is a key concern to use as part of your liaison with them as well.
And just thinking about that back within the risk framework, I think that the challenging areas for us as engineers, design engineers, are in the intermediate ground. So, for a very tall building, you can say, okay, you obviously need sprinklers, you need to cover up a lot of your timber, you need to use timber that's, not going to delaminate if you're exposing it, very clear rules. Low rise, also very clear rules. You can say very low risk, everybody can get out. So an important part for us is where it switches from sort of a low risk to a medium risk, or a medium risk to a high risk. And a big thing from a fire engineer is, we think about if you can evacuate the building simultaneously. So if the building's small enough that the stairs can be designed, large enough without taking up too much room to get everybody out in one go, then that's a certain category of building. But as soon as you can't evacuate everybody instantaneously, you're keeping people inside the building. And as soon as you're keeping people inside the building, your design criteria must go up a notch, and then once you get to even taller, not only are you keeping people inside the building, but the risk of people being trapped above the fire increases when you've got more floors, so then you go up a notch again.
And we've briefly touched on some of the challenges that you might have for an office building, like the increase in fire load. What are some of the other specific things specific to timber that we need to be looking at? And then obviously the follow-up question is, what is the solution to improve your confidence in the fire design?
Yep. So, and it's related to the increase in fire load, but the larger point is, for a large open plan compartment with combustible surfaces, is we actually don't know an awful lot about how the fire dynamics works. And part of that is the additional fire load that is added in from the structure. But also part of it is, how the fire spreads, because it's, and it's to do with opening floor space and, your floor fire load and everything. But actually what we've seen in some of our models that we run, and what we've seen sort of anecdotally in some of the experiments that University of Queensland are looking at, is you'll have a fire. It'll start off as normal. Let's say it's in an office, it's a workstation. It'll start burning. It'll start radiating out. And then the timber above it will become involved, but then it's also radiating to adjacent timber and radiating to adjacent timber further away and spreading to desks nearby. But we're seeing this localized flashover, so whereby a fire can sort of accelerate across the ceiling, let's say, way in front of the seat of the fire, way more than you'd expect for a non-combustible building, which is, we think it's short-lived, but this has never been validated by tests, so we're going to get on to testing in a minute, and that's probably the way to increase confidence. But what we're seeing, it's short-lived, but what it does is it re-radiates back to the desks underneath, and then that accelerates the fire spread. So what we'd probably say, probably a watch it, is you're likely to get far more rapid fire spread if there's a combustible surface involved, particularly overhead. And I guess the other one for me is if you've got a number of combustible surfaces next to each other, let's say a wall and a ceiling, then you've got re-radiating surfaces, which we've definitely seen from tests, and it is a conclusion that you can draw from room tests, because they've done these things that you get a lot more energy release in that situation. And it's the classic, when you're trying to start your campfire, if you've got one log burning and it's kind of looking like going out, if you put another log parallel to it, then they'll start radiating off each other and the fire will get going again. So,
and continuing on the analogy of the log on the fire, another thing that happens when you throw the log on, it kind of chars rather than burns through, and so it maintains a bit of structural integrity. So how do we utilise this in the design of the structure?
So I guess fundamentally, with mass timber elements, they do behave in slightly different ways. So glulam will char slightly different to CLT, and similar with LVL. Primarily, we're seeing a lot of popularity in glulam and CLT. So I guess in terms of the charring itself, it's effectively creating an insulating layer to the underlying and remaining member, and it's looking at the behaviour of the remaining member in terms of, can that achieve the structural adequacy required for the building.
on the point of charring, so obviously when timber burns, it chars, which is basically forms an insulating layer around the sort of edge of the beam, log, whatever's burning, which protects the wood inside. And it's a really commonly adopted design methodology that you can actually allow for this char layer to build up, and however much timber is left inside after the required fire resistance period, if they can carry the structural loads, then your building's good to go. And this is a really commonly and well respected design methodology. The bit where we come in really is there's a lot of complexity in determining how much chars, how fast it chars, how much chars, therefore how much is left at the end. That's the ultimate goal, is to get to how much is left at the end with confidence. But into that goes a lot of stuff. There's fire dynamics, there's the timber type, there's the adhesive type, there's the the type of building you're in. There's a lot of complex stuff going on at that end so that you can come up with how far will it char, how long will it take to char, and how much will you be left with at the end.
And I think just taking that one step further is it's basically been said that once you understand, some people say, oh yes, it's as straightforward as there's a simple degree of charring that you can apply and no problem we achieve the FRL. But as Rob touched on, there's a number of points in terms of the complexity of that really takes it further a notch. And I guess with these new engineered timbers, they don't necessarily all behave in a similar way. In fact, a lot of them behave in very different ways. And particularly there's a difference there with glulam and CLT. And that's where you start to see, or you can start to see, some delamination of layers. And that's where some codes are now trying to take that on board and utilise that in their revised update of codes.
And so what impacts delamination, and how do we reduce that so we can actually rely on the charring?
Yeah, so the glue is the main impact on whether the char falls off or not. We're supposed to call it char fall off rather than delamination apparently, but anyway, so it's the glue. So a lot of the glues at the moment that are used in CLT, and certainly some of the earlier sort of forms of CLT, are they're not particularly resistant to temperature when compared to the surrounding wood, so they tend to fail at around about 200 degrees, whereas the wood chars at around about 300 degrees. So you can often, and has been been observed in pretty much every full scale fire test, that a layer will fall off. But saying that, and I think it's probably the sort of the sea change for the CLT industry definitely, is that people are developing higher temperature resistant glues. So there are some other glues which require like some formaldehyde glues and things like that, which are brilliant for temperature resistance, but they require a completely different manufacturing process for your CLT. So CLT, particularly the stuff manufactured here in Australia, and a lot of the stuff that comes from Europe, Austria, are manufactured with polyurethane glues. And there's a lot of work being done on producing higher temperature polyurethane glues so that they can be incorporated in almost the same manufacturing process. And I think from a predictability point of view, from an engineering, fire engineering point of view, there's been some published papers on this, and with some higher temperature PUR glues, CLT basically acts like a block of wood, a solid block of wood, and you don't get the accelerated charring. It's a lot easier to deal with. It's a lot better for us to design for.
I was just going to add 2 points to that. One being in terms of a calculation, and one being, I guess, lessons from elsewhere. And we're starting to see, I guess, whilst we see that the ABCB and the BCA updates locally, they're not quite as up to date. They don't progress as quick as some of the other codes, but that allows for additional performance-based interpolation and assessments to be undertaken. So I guess as fire engineers, we can't really argue that point. But On the flip side, there are codes, like within the US, and they are really up to date and really move with a lot of the research that's occurring, not just in timber but across the board. In which case, typically a fire engineer is really assisting a design team to meet the prescriptive code. Like, it's still quite complex in what they're doing, but it's meeting the code rather than expanding beyond the code. So their recent changes in terms of they've done a lot by way of fire testing, and they've recently made a call to only use heat-strengthened glues within their CLT supply chain, or those who want to supply into the US need to have those such adhesives used. And so that's also to support their increase in height for timber buildings. So effectively it goes back to what we originally were talking about, which was with an increased building height comes a need to consider the amount of exposed timber, but then also the type of adhesive used and the char fall off or delamination that's occurring through that process.
I think just to expand on that point, lower temperature PUR glues, the traditional ones, they absolutely have their place. That they for sort of CLT that's going to be covered up or in smaller buildings, then absolutely that works a treat and no problem whatsoever. I think if you take the example of a tall building, as Travis was talking about then, and it's not just a timber building, it's any building. Once it's tall enough, you have to design for burnout. You have to design for the whole floor and all the fire load within that building to burn out, to allow people, the appropriate level of safety above them. Above the fire floor, sorry. But in order to demonstrate burnout, it's really difficult if in a timber building, if a layer falls off and that then falls into the fire, so it has a double effect. So it's not only is it adding fire load, it's also exposing fresh timber. And what we see in fire tests repeatedly when char fall off occurs is the fire will almost die out, releasing no energy, and then with char fall off will occur, and the energy release will be back up to exactly the peak of what it was before. Sort of 6, 7, 8 megawatts, like big fire from nothing. And obviously, if you're sort of applying that into a large building where there could be people trapped above or people trying to escape past, you just can't have it. So this is why if a higher temperature glue is developed and you can confidently say char fall off won't occur, and then as the fire dies down, that's it. Your fire's died down and you've demonstrated burnout. If you're like very confident that it's not going to fall off and lead to that second energy peak.
And is there any in a real fire? Is there any opportunity of self-extinguishment and can you assume? Is there any way to assume this in your design, or is it actually a real thing that happens in reality?
The short answer is yes, it can occur, but there's a number of things that needs to be considered. So one is instant heat flux, so how much energy's on the surface, and also the sort of airflow across the surface as well. So I think UQ, when they did their experiment, they started from a position of can we demonstrate it works, and they're coming from a purely academic background, and absolutely fine. They want to show that it works and then vary the parameters through future experiments to understand what are the critical parameters that influence self-extinguishment. But so they set their experiment up with like the perfect airflow across it, the perfect fire load, perfect opening characteristics in the setup rig, and they demonstrated that self-extinguishment was achieved. But that, and it says in the paper, this is not applicable to building design. Like their fire load was very low. It's probably like 10 times lower than what you'd expect in a building. So it's very difficult to apply those conclusions to a real building. Yeah.
But I think the thing is trying to take that further is it's obviously a key phenomena, and if that can be solved, then that's a massive leap forward for the exposure of timber. But I guess fundamentally, our answer would be the way we're seeing it and the research at the moment is that it's in its infancy, and there's a lot of work that needs to be done to really test the parameters at all ends and considering all facets that go into that. Interestingly enough, at the upcoming Pacific Timber Engineering Conference in Brisbane, there are a number of papers that are looking into self-extinguishment. So that'll be interesting about what's happening in with research and institutions at the moment. And I think Rob's up there talking as well.
Oh, and so we've covered the risks in a bit of detail. What are some of the solutions on offer for fire engineers to adopt to leave some timber exposed?
Yeah. So I think primarily it needs to be part of a holistic design. It's just one component that needs to be considered alongside all the rest of the risks within the building. But obviously sprinklers are a must pretty much once you get over maybe 1-2 stories, maybe not. But that again, that's just one component as well. It obviously depends on the building characteristics and the size. You've definitely got a lot more scope when you're looking at lower rise buildings, medium rise buildings. Once you get into taller buildings, then you really have to looking to cover up a good portion of the building. Then it's down to sort of managing the architect or the client's expectations as to how much timber they want to see. Not saying you have to cover it all up. That you can certainly expose some. You can certainly, and you can enough to come up with sort of a nice architectural look. But we definitely need to manage expectations once you start getting to the taller buildings. And the other thing for things like that, I mean, there's some practical advice, obviously. So looking at the higher temperature glues definitely gives some advantages with potentially exposing more timber. Using timber as part of a composite system with a concrete or a steel frame, where you might have you'll probably get your weight savings and some architectural sort of impact from exposed timber soffits. Then again, that can sort of really lead to being able to expose more and more. But again, it's still always going to be limited. I think just some practical things like breaking up combustible surfaces. So if let's say the architect wants to show off like 40% of the soffit or something like that, then you can choose the most sensible 40%. And you can sit down and see where that works between you both. And I think where we're coming from with this is, we're trying to. There's a lot of money been spent on the timber industry. We're absolutely for the timber industry, 100%, and we want to see large timber buildings go up, and a great future in timber. But just we're at the beginning. We don't want something to go wrong and jeopardize any of that. And also when, until some larger scale tests have been carried out, which I know is in the pipeline, definitely talking to University of Queensland, they're planning on that, but it's a little bit of a way off yet. And then, once that's done, we can properly validate our tools against that, rather than coming up with best guesses, which is what everybody's doing at the moment. But just with the uncertainty that exists, our best guess needs to be on the slightly conservative side,
And I think as a result of that there, in the industry, what we're seeing with performance solutions in mass timber buildings is, and I think this is the right way to go about it, is the fire brigade are saying, look, that's a highly technical area that we're not quite across. We would like to either reserve comment on the structural side of things itself and push for a peer review. And often building surveyors are asking for a peer review of timber designs as well. Or they're suggesting that it goes via the Building Appeals Board for independent review and assessment that way. So I think at the moment that's doing the right thing, but I think it's just worthwhile that design teams are aware of that there are these unknowns still in there. And as a result, you just need to be cautious about how far you apply the current research and take that forward. Hence, I guess the big difference, what we come back to, and where, as you said, your previous podcast was looking at the deemed to satisfy and against the performance solutions. And effectively, we're going from one solution, which is completely encapsulated timber, to the other side, which is completely exposed timber, and moving that into higher and higher buildings. So we just need to make sure that we're considering all of the key items that are coming out of the research and addressing them appropriately, and scrutinising one another in that aspect as well. It's not trying to necessarily shut down another engineer. It's trying to work with them and collectively everyone upskills together, project by project.
For both of you, what do you see as the future of timber construction from your own experience and the projects that you were seeing coming on the table, and what kind of acceleration are you seeing as well?
Well, we're certainly seeing a lot of concepts. I mean, not all of them make it to buildings or even further through the planning stage, but just the sheer interest in concept designs that we're having to look at, it's I don't know, it's gone from, in the last 2 years, it's probably gone from, I don't know, one in the year to one a month now. So it's seeing a huge acceleration. I think, obviously, when you get into larger timber buildings, it's a new industry. There's nothing new about timber, but timber for large buildings is a new industry. We're all learning. The designers are learning, the academics are learning, the approval authorities are learning, and hopefully we're sort of converging on some results, some techniques that we can use to sort of push this forward, and turn a few more of them concepts into real buildings.
Yeah, and I think in terms of that, I think it's pretty critical to ensure that there is engagement between academics and engineers, and I guess a lot of reality with where, I mean, if you work together, you can get to some good places, and I think that's where we want to make sure that we are. In the past, there's been a lot of separation and segregation, and therefore there has been a need to, not just in terms of timber, but in terms of fire engineering in general, try and extrapolate from an analytical part to a test and try and pull it all together. Whereas if you work together, you can have a good degree of confidence, and I think that's where we're moving towards. And I guess you'll now see that at a lot more engineering conferences and timber conferences, where you've got engineers and academics talking at the same events and getting along and collaborating. And I think that's a positive way that the market's going. And then I think just in terms of those concepts, is certainly, as Rob said, and they're just the ones that you hear about or that you come across from talking to others, it's becoming more and more popular, and certainly pushing that performance side of things. So yes, there's a bunch that are going down the deemed to satisfy path. That's fantastic. And it's great to see. And the more that come up, there's a lot more certainty with costing and programming. As a programming, that's a massive element. And then the more that's learnt from the projects that are coming up, it's then starting to push the boundaries of that into that performance realm. So I guess we're seeing these more overbuilds at infrastructure, existing infrastructure, or then we're seeing an extension on top of existing buildings. We're seeing completely new buildings, all exploring this mass timber and exposed mass timber, or wanting to explore that path. And it's just it's a great time to be operating in this environment, I think.
I think one thing I'd like to see as well is like the industry sharing knowledge, and I completely understand there's been lots of tests done on projects that are protected by intellectual property, and that's absolutely fine. It's it's a commercial business and probably cost a lot of money, so absolutely fair enough. But I think we're more trying to push along the path of sharing everything we find, because. And certainly this is why we're partnering with universities, because it's, in a more public realm, it'll be available to everybody. The idea is to sort of educate everybody in the industry, ourselves included, but everybody.
Is there anything, as we're wrapping it up now, is there anything you'd like to leave us with? What are some of the work Arup's doing that we should be looking out for? And if people want to get in touch with, or if people want to get in touch with you for any jobs they got in the pipeline, how do they get in touch?
Yeah, okay. So essentially, there's probably a couple avenues to answer that. Where, as Arup, we invest roughly about a third of what we make in our own internal investment, and that's through regional investment funds and global investment funds. You essentially put together a bit of a proposal, and it gets reviewed, and then if they believe that it's for the benefit of I guess, where Arup would like to go and where we're seeing clients wanting to proceed, then that's one, I guess, in short, that's where we're heading, or where we have been for some time. Now, in terms of that, in that timber space, Rob and I are involved in a bit of a regional timber and global timber network with Arup, and so we are involved in some bi-monthly calls where we catch up with what's happening in the US and London, and linking in with our office in Singapore as well. And so we have a big connection, and we're just talking about generally what's happening in academia and whether there's any leads or technical issues that we're trying to share around, because we've obviously got some better knowledge in some areas than others. So that's probably part of it. And then obviously continuing with that investment is looking at our own tools where we can then start to extrapolate from some of these tests, not too far, but trying to align them with a number of the tests that have been done to validate where these tools are going, particularly in that exposed timber space, and applying it to larger compartments and the contribution of the timber into the fuel. So that's probably where we're looking at the moment, and we're really trying to push the bounds of that and test it a bit further. And then I guess from a projects basis, as Rob touched on earlier, I guess we often see that there's a number of concepts that start, and then they may not come to fruition. We're starting to see a few more of those convert, and it's great to be involved in those. We've got some through at planning, and then some that are just proceeding beyond that at the moment. And then there's obviously a number of ongoing peer reviews, again, which I touched on earlier, about what the expectations of the industry are when you're trying to step into this performance-based realm. So that's I guess where we sit at the moment, and more than happy to talk to anyone if there's inquiries about it, or if they're looking to pursue that sort of a concept.
Yep, fantastic.
Yeah, likewise, more than happy for anyone to get in touch if they want to. My email address is robert.dixon, Dixon, @arup.com. Get in touch. Happy to chat timber anytime. It's an exciting space, and definitely one we want to sort of continue developing.
If you want some free generic advice on both the DTS provisions or the performance approach for your project, the Wood Solutions team will be able to help. You can contact me directly at jones@woodsolutions.com.au, and I'll put you in touch with the right team member.